In addition to central tendency, there's another measure that you could use to represent data, and that's called dispersion. And it describes the spread of a data set. So how far apart are all the values? Are all the values really close to each other, or are the values very far away from each other? Are there outliers? How are they related? Okay. The simplest measure of dispersion you already know about, and that's the range of values, and it tells you how far apart things are. So, example 1, 2 reality cooking shows select 12 contestants each. The ages of the contestants are shown in the tables. Find the mean and range of the ages for the show. And pause the video. I want the mean and the range for each show. Pause. So if you look at their means, their average age is about the same. However, the spread of ages in show B is much larger because the range is larger. So show B, actually let's say the ages of show B, or the ages of the contestants, the ages of the contestants for show B are more spread out. There's another measure of central tendency, and this is a very new one, and we're going to go a little slow on this, is called standard deviation. And the standard deviation tells you how much each individual value differs from the mean. So is the age of contestant number 1 very far away from the mean? Is the age for contestant 2 very far away from the mean? Is the age for etc.? So you can find out how far away you are from the average person by doing what's called the standard deviation. So we've got this super, super crazy formula, and there's this new symbol right here, and you read that as X bar, and that's what we do to represent the mean, and it's read as X bar. N is the number of values. So it's just like any formula you've ever done before. It kind of looks a little like the distance formula, if you remember the distance formula. That's kind of weird. I just thought of that. But so we take one person's value, subtract the mean, square it, plus x2 minus x bar squared, plus, dot, 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 like etc. Like you do x3. So this means it continues until you get the very last person minus x bar. All divided by the number, and then you take the big square root. It's super crazy. You just got to find your values and plug them in very methodically. So here's what that really tells you. If you have a small standard deviation, then everybody is pretty close to the average. If you obviously then, on the flip side, have a large standard deviation, then everybody's values are very far apart, or at least the spread is very big. So instead of having like a 15-mile long square root where I do all my math underneath and then I divide by, like one little number, I'm going to set up the standard deviation formula in a chart style, so that way it's going more horizontal, or it's going more vertically than it is horizontally, because I'm trying to avoid having this very, very, very long square root, because you can imagine each little piece takes up quite a bit of space, because it's a subtraction plus another subtraction plus another subtraction plus another subtraction, and that's only like 4 values. If you have 30 values, it's going to be a very wide square root symbol. So I'm going to set it up in a little chart, but it's the same formula. So if you like doing it horizontally, I don't want to stop you from doing it horizontally if that's the technique you'd rather do. Just plug in the values in the horizontal method. Now these 5 steps here are the steps to find the standard deviation. So first you have to find the mean, right? Remember we called that x bar. Then you have to find the difference between each value and the mean. Then you're going to square each difference. Then you're going to find that mean of the squares, which is when you divide by the number, because that's how you find the mean of anything. And then we're going to calculate the square root. So if you're looking at the square root formula, or I'm sorry, the standard deviation formula, these steps are how you would calculate it. But again, instead of using a super long square root, where I do all the stuff here, I'm going to do it in a table method. So the first thing I'm going to do is I'm going to find the mean of the data. Now remember, I actually already did that earlier, so I just grabbed it right from that question from before. So now in order to do the next part, which is to find the difference between the data value and the mean, I have to set up the chart that I was mentioning. So here it is. X is going to represent this specific value, so I'll fill that in. And these are the ages of the people. So I'm just filling it in right from the example. And then this column here represents X bar, which is the average. So that's going to be the same no matter what. So I'm just filling in 25 all the way down the table because X bar doesn't change. What will change is the value of when I subtract. So now I'm going to take this value, subtract the X bar, which is the average. So I subtract, this one gives me -5, this gives me 4. And you can see, obviously, you could do this on your own. So hopefully I'm going to zip through it pretty quickly, and it shouldn't take you that long to copy with me. The next column that I have to add, I'm actually going to add another column, and it's this value squared. So my title is X minus X bar squared. And hopefully you see these pieces in the formula. Again, this is just a tabular way of showing the standard deviation formula, so I don't need a very, very long square root symbol. So this is 25, 36. Oh, no, that's 16. This one's 36. And again, this should be something quick that you can do on your own. All right, now the next part of the formula is to take these values, add them up, and divide by the quantity. So I have 12 values. So what I'm going to do is I'm going to add up this column and divide by 12. So now I got 17.7, and then the final step is just to take the square root of 17.7, and then, do they want me to round? Nope, it doesn't say to. So usually you go to the 10th, so that is around 4.2. So each age is about 4.2 years away. So 4.2 is the standard deviation. And I will interpret up here because I forgot to interpret. So this means each age is about 4.2 years away from the mean. Obviously, some ages are closer, some ages are further away, but the average age, or most of the ages are 4.2 years apart. So obviously, with a larger standard deviation, your ages are going to be more spread from that mean. Smaller standard deviation would be closer to the mean. If you would like to try one on your own, I will tell you that the standard deviation for show B is around 7.5. So if you want to test it out, see if you can try it on your own, it's optional, but you should get around 7.5 as your standard deviation for show B. If you have any questions, write them down and ask me when you come to class.